Inspired by Nonoleaf shapes, I decided to make similar lightbox but much cheaper. For this project, I'm gonna use WS2812b addressable LED strip with ESP32 controller. Additionally, I need a Type-C charging port, capacitors, resistor, few connectors and wires. The panels will be self-designed in Fusion 360 and 3D printed using PLA. Before we start, let's do some math. I will have hexagonal with 5 cm side length, so the perimeter is 30. My LED strip has 60 diodes per meter, which means one section contains 18 diodes. To allow some spacing, I'll use 17 diodes per section. Each diode consumes 60 mA at maximum bright, so a section consumes nearly 1 ampere when all diodes are lit on 100% brightness with a white color. That's a significant current, so you should ensure your electronics are able to handle it. For example, if the section only light up with red, the consumption is reduced 3 times. By taking this advantage into consideration, we can move forward. To avoid reinventing the wheel, I'm gonna use WLED to control my strip. Open install.wled.me, plug USB, select correct port and press install. After installation, you'll be prompted with setting Wi-Fi credentials. Once credentials set up, I'm opening App Store, download WLED application and running it to check that ESP successfully connected to Wi-Fi. The wiring itself is pretty straightforward. On the LED strip, I soldered the black wire to ground, the red wire to plus 5 volt and the green one to data. I connected ground to ESP and the positive wire to WIN. The data line will go to GPIO2, but it doesn't really matter since it can be changed in WLED application. Now I'm connecting power supply and checking everything works. I'm starting the modeling process from a sketch where I defined a hexagonal shape with a wall thickness of half centimeter. The panels are connected through interlocking slots, so I'm adding a joint to each side. To secure the LED strip, I have designed a small clips along the inner edges of the panels. After extrusion, I'm adding a wire passages through the panels and small phase offset to the joints to compensate for printing imperfections. The panel cover has a honeycomb texture and snaps into place. It's 1 mm thick, with the textured part being a bit smaller. This way it should diffuse the light smoothly and evenly. Then I duplicated the panel design and added wall mounting brackets. It took some time to print test panels. After cleaning all the supports, I can finally check if slots fit together, and thankfully they do. Now I'm placing the LED strip to see how the assembled panels look. I couldn't find LED connector, but I have plenty of JST connector at home, so the most painful part of the assembly begins. First, I need to cut the wire. Since I've decided to make 10 panels, I'll need 10 wires for each color. After cutting the wire, I'm adding crimps to them. Since my crimping tool is still in China, I'm doing this by hand. For added security, I'm soldering each connector. Now I'm inserting the crimped wires into each connector, ensuring the sequence is identical for every connection. Once the connectors are ready, I can move forward. As being said, I need 10 pieces of LED strip. I'm trying to cut them as precisely as I can, but after making so many JST connectors, my hands are starting to feel numb. Talking about connectors, I need to split them too. The male connector will be soldered to one strip end and the female connector to the other. Soldering is fairly simple, but I'm trying to keep the wire insulation as close as possible to the strip, which requires a bit of skill. For the first piece, I'm soldering a capacitor. It's really important to get the capacitor polarity right. Getting it wrong can cause it to explode. Although my flux doesn't require washing, I still clean it off with isopropyl alcohol. This removes the stickiness from the soldering area and reduces the risk of short circuit. Finally, I'm able to assemble all LED strip pieces and test them together. The last thing I missed is a box for electronics. I'm creating a very rough model to house ESP and improvise board. I want to secure everything with the screws, so I'm designing the box with that in mind. To ensure all connectors and wires are neatly hidden inside, I'm adding extra space, a hole for JST connector and a slot to attach the box to LED panel. I decided to keep the lid as simple as possible. I'm leaving plenty of ventilation space to prevent overheating and to make the design easier to replicate. With this approach, you don't need extreme precision to align the USB Type-C port. After printing the box, I'm ready for electronics final assembly. First, I add a resistor between the ESP pin and the data pin of the LED strip. Next, I place all wires through the holes and secure my board with 2 screws. While soldering the wires directly to ESP is an option, I prefer to use connectors so I can reuse my ESP for the other projects later. I'm placing the LED strip into 10 panels, making sure the connectors are as close to the holes as possible. Now I'm connecting everything together and attaching the Honeycomb LEDs. Finally, it's time to the final test. Speaking about numbers, this project costs me $4 for filament and $28 for electronics from local store. You can find the list of components and link for 3D model in video description.